So hi guys, today we have another problem that is find the closest number, and basically you are given an array and a value of k. You have to just tell if the value of k is present in this array or not. And also this will be sorted. So obviously this is the question of binary search, and there is another condition that the value of k may not include in this array, but you have to return the closest value of the k if that condition happens. If you can find the value of k in this array, then it is okay. Just return the value of the k, and else you have to return the closest value of the k. So that's it. That is the question. And also there is another condition that is, suppose you are taking this array 1, 2, 3, 5, and the value that is 4. So obviously 4 is not included in here, and you have to return the closest one. So what can be the closest one? Obviously 3 and 5 both, because 4 lies between them. So which one we have to return? The greater value. The greater value we have to return basically. So this is the question, and obviously you if we have to include the binary search here and modify a little bit, so we can have the closest value of the given value. So let us think about it. What actually binary search does? Basically, let us take an example. Suppose 2, 3, 4, 9, 11, and the k that is 8. So obviously k is not here. And if we simply use binary search, then what happens? This is the position of L, this is the position of R. Mid will be here, and obviously k is greater than mid, so we can discard this part, and new L that will be here, mid also will be here, and k is lesser than the mid, so you have to reduce R here. Basically, R will be here, so it will cross R, right? So we will stop here basically. So if we carefully observe that it is the position of L, that indicates that one of the closest value of 8, this is right. So at the end of the procedure, we can have the closest value, but we do not know which one. Means if suppose there is a part of the array that will look like this 8 and 10, and the value of the k is 9, then you may got this value or this value. So we have to determine which one I am getting and which one I have to return that will satisfy the condition. So how can we get the condition? Obviously, we have to calculate the absolute value of those. So the absolute value of 8 and 9 is 1, and 9 and 10 is 1. Now look, both the absolute values are same. So we have to return this one. So this is clear. Let us consider another example, that is 4, 5, and 9. 9 is like 5 is the value of k. So here absolute value is 1. Here absolute value is 4. Yes. And which one I have to return? That is 4. And how can I know it? By saying the absolute value of both two elements. Okay. So as I have told you, I can get this value or this value. So we have to make a condition. Basically, the thing that will be splitted by 2, and let us consider for this case when we are getting the leftmost values. Let us take example, that is 2, 3, 9, and we are getting the leftmost value. So how can I get this value? That is, if suppose this is L, this will be L plus 1. and obviously k is an arbitrary target, so it will be not included into our array. So how can we get the next value? That is n12 plus 1, obviously. And now we have to calculate the two absolute values. How can I? That will be, suppose a is equal to abs of this one. Basically, this is k l plus, sorry, a- array of l minus k, and b will be abs of a l plus 1 minus k, right? So now which one I have to consider? If this is less, then obviously we will consider 2, right? Because the value that we are making from a of l and k. So if this is less, we will consider 2, and if this is less, then we will consider this one. So the condition will be a, if a is less than b, then we will consider a of l. Otherwise, we will consider a of l plus 1. Again, we have to keep in mind, if the value of 2 and 3 and 3 and 5, suppose here is 9, I am changing the value with 4. Where is the eraser? Okay, suppose this is 4. So the value will be equal, a and b will be equal. In that time, we have to choose for the bigger one, right? So the condition is satisfied or not? Let us check it again. Suppose a is 1, b is 1. So this condition is not satisfying. So we will take this one. So it is matching. If the value of a is lesser than b, suppose this is 2 and this is 5, then we will consider this one. Otherwise, if this is greater than this one, then we will consider this one. So this condition is working perfectly. So we have to make another condition for this part. We know how to calculate a and b. Just we can copy this, copy and paste. So we can copy this, and obviously this value will be changed, and it will be, sorry, where is my eraser? It will be L minus 1, because now we are considering the previous value, means currently we are we are on this position and we have to get this position, right? So L minus 1. Now A and B are calculated. And what will be the condition? If A is less than B, then we have to consider which one? That is this one. And what is the value of this one? That is A of, we can consider A of L minus 1. Clear? And let us check for another condition. Suppose this is lesser. So we are considering A of L, and if both are same, then also we have to consider this one. Means we have to make an equal sign also. So let us try to quote the concept. That is, let us first of all write the binary search here, equal to 0 int r is equal to 1, while L is less than null. We have to continue. Mid will be L plus R by 2, and if Pair of meat is greater than the k, then the k is lesser than meat. We have to reduce the r. That will be r is equal to meat minus 1, else L is equal to meat plus 1. And lastly, we have to check for those conditions. That will be error of L. If this is less than what? K means which condition? If it is less than K means this condition. Okay. So we have to apply this condition. Simply, we can copy paste from here. That is uh, return, sorry, APS error of L minus K. If it is less than APS of error of L plus 1 and minus K, then we have to return which one? That is error of L, else we have to return error of L plus 1. Perfect. In the else part, we have to consider this condition. We can just copy from here. Okay, and it will be minus 1, obviously. So this is B, this is A, and we have to make it minus also. And the condition that will be equal to. Let us try to run the code. So this is working fine. Let us check for this one. This is also working fine. Let us try to submit the code. Perfect. So this is how you can make the approach. And obviously the time complexity will be log n, and I am not using extra space. So yeah, this is how you can deal with this question. And thank you for watching. Bye. See you in the next video.